All right, so on number 7, I would assume most of us had issues because one had a fraction in it. Okay, it had a fraction in it. There are some key words that we're going to work with here. I'm going to read this out loud and we'll start working. So the first thing we're going to do is we're going to identify the question. The question's at the end of the problem, and it says, and I'm going to paraphrase for you, how many more sessions? All right, so we're looking for sessions. This is the important thing. It's our unit of measure, number of sessions. Okay? Now, so we trim the fat basically because that's our unit of measure that we'd be looking for as we go back and look for the passage. So our next thing is we're going to look for numbers. All right, the numbers that we see in it, I'm going to read the passage to you. It says, Allison practices her violin.
Coach Wallace?
Yes?
Cristela Morales needs to come to the office, please.
She's not here.
All right, thank you.
All right. Allison practices her violin for at least 12 hours per week. She practices for 3/4 of an hour each session. If Allison has already practiced 3 hours this week, how many more sessions remain for her to meet or exceed her weekly practice goal? So meet or exceed means that we're going to have a what kind of inequality? Meet or exceed. Greater than or equal to, right? Exceeding is greater, and meet means it's an equal to. So we have an equal to here. All right? So the numbers that we have in the problem were 12, 3, 3/4, and those are the numbers that we had. So 12 was hours, okay? 3 was hours, and 3/4 is our rate. How do we know that 3/4 is the rate for the hours? Say what now? And the 3/4 of it says 3/4 of an hour is going to be the rate of the hours for each session. So this is our rate of change. It's our rate of change. And so from there, what do we need to do to, first of all, write the inequality? How many hours are we working with in the remainder here? We have 12 total. So this was our total hours as she practices. So we have 12 total, and this is how many we have practiced. Correct? And so we take those away, and the hours that I'm working with are 9. Correct? So what we're looking for is we're looking for how many sessions practicing 3/4 of an hour is going to engulf 9 hours of practice. That's what you're really looking for. Okay? And so in doing it, here is our total. And we want to meet or exceed it. So if I'm going to meet or exceed it, then I need to be, I know it's written as less than or equal to, but our number of sessions is going to be greater than or equal to 9 hours. Correct? And so what's the rate per the hours? Per the rate per the sessions. How much does she practice? 3/4 of an hour for sessions. Now, some of you could do this a different way. Instead of subtracting it right here, you could have went 12 total hours is what she practices. Okay? She's practiced 3 hours already. And then our rate is still this. And we'll call it S for sessions. Now, so if I get 3/4 of an hour per session, I add 3 hours to that because that's what I've already done. So what happens when I add that and move it over? It's going to be 12 minus 3 to give me 9. So both of these inequalities are correct. This is also in a linear form. We have a rate, we have a y-intercept, we have an input variable for sessions, and we have a specific output of 12 hours for y. All right, what do we do to solve it? Okay, so convert it to a fraction. Some of us are converted to a decimal. Some of us can convert it to a decimal to get 0.75 s, and therefore for you it looks like just a regular number. So you divide by 0.75, divide by 0.75, and what do you get? Do we flip the sign? No, it's not negative, and we get 12. Now here's where you got to know your units of measure. Is that 12 hours? Because that wouldn't make any sense. Because if I need to practice 12 hours, I've already practiced 3, and now I'm back to 12 hours. What does 12 represent? The number of sessions. So you got to know your units of measure. All right. Now, there's another way that we could solve this if we didn't convert it to a decimal. All right. I wish you would get a little more familiar or comfortable working with fractions, because those are numbers. It's just two numbers on top of each other, and once you start converting things to decimals, sometimes you're not going to know what the decimal represents, or it's going to be a repeating decimal like 1/3, and that's going to be 0.33333333.
May I have your attention, please? All seniors need to go to the gym at this time.
Okay, so that's going to be 0.3333333333, and so you're going to round that, and once you round it, your answer is going to be rounded too. And so it's better if you work with them as regular numbers. So right here, what we have is we really have 9 is less than or equal to 3s divided by 4. That's what we really have. So if I'm going to get those off of it, I got to multiply by 4. That's going to give me 36 less than or equal to 3s. Now divide by 3. So that's going to be S is going to be greater than or equal to 12. Okay, I wish that you would get more comfortable with working with this fraction. Instead of converting it to a decimal, most of the time you won't know. I mean, 0.75 is an easy one. We know that what that should represent, 75 cents, whatever, however you want to break that down. So that's easy for us to recognize, but it's easier to work with numbers if you can see fractions as numbers. All right. Now lastly, we're going to check the number line. Okay, so I'm going to put 12 in the middle. Number to the left is 0. Number to the right, we'll pick 15, because I don't want to pick 13 because that's unlucky. So we'll pick 15. All right, I plug 0 in to my original equation. That's going to give me 9 less than or equal to 0. Is that true? That's not true. So therefore, if I plug the other one in, 15, so it'll be 9 less than or equal to, what is 45 divided by 4? I got a calculator right here. It'll be 11.25. Is that true? That is true. All right, and it's equal to, so my shading should look like that. Questions?